All right, good day and welcome back to Everything Mathematics. And today we're going to start our new series. And this series, of course, will cater for the advanced students. In this case, I'm particularly doing this to assist two of my students, Tiwa and Mackenzie, as they undertake the additional mathematics exam, hopefully later this year. And this is one of the topics in which, as I introduced to my students, it's a cool thing to be able to find the square root of a number without having to use a calculator. For example, if you understand surds, we will be able to, of course, find something like the square root of 100 without necessarily using a calculator. What is a surd, you may ask? Simply put, a surd is basically a number written as a square root form, but in its lowest form. That's how I like to look at a surd. So it's a number written in its lowest form as a square root. And understanding that, of course, help us to bring two other things into play. A perfect square or a perfect number, well, it's not a perfect number, it's a perfect square, and of course, that of an irrational number. I always tell my students that a surd genuinely lead to an irrational number. So for all of the math students out there that always wondering what is an irrational number, how to think of an irrational number, think about a surd. If a number can be written as a surd, then it's automatically irrational. If it cannot be written as a surd, then it's not irrational. It might be irrational or some other type of number. But once it could be represented and written as a surd, it is an irrational number. Surds generally look like this. So as I said, we have a number and then you have something in a square root, something like this. So this is basically what is a surd. Algebraically represented, you might have a square root b. Good. And as I said, whatever is inside of the square root cannot be square rooted. And yes, earlier I said it's a nice way to square root numbers without using a calculator. And yes, that's true, but that is for perfect squares. And once you know surds, this will help you with your perfect square. So that brings us straight to rule one, and then I will show you how to go about actually finding, breaking down square root. By looking at the rules, it will make our life a lot easier. So rule one, when it comes to surd, and yes, today we're going to only be looking at rule one. The following videos will have several parts, and each part will be looking at various rules. I think I will isolate the rules. So rule one, when dealing with surd, states this. It tells us that if we have something under square root, let us say, oh, this one go kind of hard to express, but okay, I'll have to use a number in this one, and I will use a number that is kind of common. So let me say we have 100, and I'll use 100 just to express the rule. And this simply, now watch, here what? Let me use algebra. I have to stick to the algebra. If I use a number, it will be too specific. So let me say I have the entire square root of a multiplied by b. Rule one simply states that we could separate these two terms under the root. So this is the same as saying the square root of a multiplied by the square root of b. That is what rule one tells us. So rule one under surd tells us that if we have this number, whatever number this is, here we have a times b, but that number can be written as a factor or the product of itself, basically. And in turn, we could segment the product. So we could have the square root of one multiplied by the square root of the other one. Good. It is also handy to understand which numbers are the perfect square. And a perfect square basically is any number in which you could find the square root and you will get a whole number. For example, 9. The square root of 9 will give us 3. Therefore, 9 is considered one of the perfect square because its square root gives you an entire whole number. And there are many. To identify the perfect square is very easy. Just take the natural numbers and square each one of them. So you could start from number 1. If you square 1, you get 1. If you square 2, you get 4. So 4 is a perfect square. If you square 3, you get 9, as we just did. If you square 4, you get 16. If you square 5, you get 25. So all those numbers are perfect square. When simplifying, of course, the square root of a number, using surds, the whole idea is basically to find a perfect square that could multiply to give you that number. And that is how we basically find the square root. Of course, that's easier said than done. Let's do a few examples and hopefully it will digest as we go. So for instance, my legendary 100. Let's start with 100. When you look into 100, you want two numbers that can multiply to give you 100. And the best way to go about doing this is by finding the highest possible perfect square that can go into the number. Sometimes you could get one, sometimes you could get two, sometimes you can get none. If you can't get none, that's okay. Then that means that you're probably dealing with a prime number, or you're probably dealing with a number that of course cannot break down any further, thus again prime. So here, for instance, we could have under the entire square root, we have the square root of 25 multiplied by 4. 25 times 4 is still 100. This in turn is the same as the square root of 25 multiplied by the square root of 4. And these two numbers here are perfect square. So here what? The square root of 25 is actually 5. And the square root of 4 is 2. So what is the answer when we square root 100? Guess what? 10. And that's a fact. We know this. The square root of 10 is indeed the square root of 10. The square root of 100 is indeed 10. But this is how using surds, or the concept of surds, rule 1, how it could help us to basically square root a number that, of course, we did not know would have been a perfect or may have known. Good. Let's look at another example. Supposing I want to find the square root of 50. And as I said, not all the time when we use surd, you will end up with a whole number. If you end up with a whole number, it simply means that you are working with a perfect square. Is 50 a perfect square? No, it's not. Is there any two numbers that could multiply into 50 perfectly, or any number that on its own could be multiplied by itself and give us 50? No. So it's not a perfect square. So using the same concept here, I could go, this is the same as the entire square root of 25 multiplied by 2. And again, applying rule 1, I could separate it. So I have the square root of 25 multiplied by the square root of 2. We just found the square root of 25, which was 5, and the square root of 2 will be an irrational number, so we leave it just like that, times root 2. So ultimately, the result here will be 5 root 2. Yep. And this is, of course, written as a surd. This is what a surd actually represents. A whole number and a square root. The square root cannot go down any lower. Any lower than this, of course, is taking a calculator, plug in root 2, get your 1 point something, 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 and multiply by 5. But oftentimes, you don't have to do this. It's perfectly fine to represent your answers like a surd in this case. Good? So let's try another example. What if we had the square root of 48? And some persons sometimes ask, is it really important to find the highest perfect square to go into the number? Now, let me tell you, the truth is no, it's not important. In fact, it's not a must. But when you do, you tend to make your life a lot easier and you give yourself less work. And I would use this one as an example. Look at the square root of 24, the square root of 144, the square root of 48. This could easily be written as 24 times 2. Good. But here now where I'm giving myself more work now. 24 times 2 will give you 48, but you cannot square root 24. You cannot square root the 2. Therefore, that begs us to break this again. So now I am breaking the 24. Let's say I'll try now 12 times 2 times 2. None of these numbers here again could break down. Of course, I could multiply these two 2's and I'll get there just now. But 12 cannot be square root. 2 cannot be, well, you could square root it, but again, as I said, you will not get a perfect square. And then, of course, I go a last time again. So I go what? 3 times 4 times 2 times 2. 3 times 4, that will give us 12, right? And the 2 and the 2, I just bring them down. And now notice I found 2 perfect squares, or potentially 2 perfect squares, because you see these 2 2's here, I could multiply them. Let me do that. When you multiply these 2 2's here, get what? You get in your 4. So you have 4 twice. So at the ending of the day, at the ending of the day, let me change the color to black again. We're ending up with, look at this, root 3 multiply by root 4 multiply by root 4, which in turn is the same as root 3 times 2 times 2. Square root of 4 is 2, the square root of 4 is 2, and ultimately giving us a response of 4 root 3. Yes, that is if we had taken this approach. And then you might ask, whoa, that looks very long. This is very lengthy. And yes, this is what would happen if you do not choose the highest possible perfect square that could fit into the number. Look at how easy this could have been done. Let's call this one an alternative method. Supposing I would have chosen, look at this, 16 multiplied by 3. This in turn would give me root 16 times root 3. And we're done here. Root 16 is the same thing as 4, and the root 3 remains the same. You see how much work this saved by finding the highest perfect square that could fit into the number? But of course, I know I'm being practical. It's not always possible because sometimes we just don't know, if we don't know what tables and if we're not versed with number patterns and so on, sometimes it could be hard to see which number could actually go into the number. So again, you use a little bits and pieces until you add up. So nothing is wrong with that. But this just goes to show that if you know your perfect squares, you can easily go into a bigger number and saves you much time in your working. Let's do one final example, and we're going to call it that for today. Supposing we have to write this as a surd, the square root of 45. I'm going to wrap it up there for today. The square root of 45, and that's of course the end of rule 1, 2, is this can be written as 9 times 5. And that's the same as square root of 9 multiplied by the square root of 5. And this, of course, works out to be 3 root 5. And that's how we basically write square root of 45 as a surd in its lowest form. So what should we get from this lesson? Two things. Firstly, a surd is basically any number, or I like to see a surd basically as a square root written in its lowest form. Let's look at it that way. Not all the time it will solve to a perfect number, but it will oftentimes solve to its lowest form. That's a surd. And secondly, if we know our perfect numbers, it will make life a lot easier when finding the surd or writing a square root as a surd, since we will have a better idea as to which number could fit into another number and saves us a lot of working. So of course, this will be the ending of today's video. As always, feel free to like, share, and subscribe if you haven't as yet. And until the next one, feel free to share. So you take